Today, our group will discuss the mechanism of self-driving cars and its possible impact on society. We will cover its mechanics, interdisciplinary concepts, and its future relationship with society. What are driverless cars? A driverless car is a car that reaches the destination without any form of human intervention. It uses various sensors connected to artificial intelligence which makes decisions on behalf of humans. Potential conflicts may arise as we adopt driverless cars into our system, some of which include law, urban planning, and sustainability.
For self-driving car, I want to talk about two engineering disciplines related to it. Like the first is computer engineering. There are many disciplines related to computer engineering disciplines. The first one is intelligent system. It's about computer vision, visual attention in perception and motor control. The second one is visualization, structure from motion. And the third one is computation modeling and analysis. The next one is disciplines related to electrical engineering applied to self-driving car. The first one is design of integrated circuits and systems. It's about the signal processing and data communication. The second is about telecommunications and signal processing. In details, it's related to digital signal processing and telecommunications network. I will provide one example to explain it better. When the car is moving, the diagonal signal processing system, which related to electrical engineering, will tell if there are any objects on the road or any other dangers. And then the intelligence system related to computer engineering will respond it quickly, like turning right or go straight or stop.
The technology that allows driverless cars to function consists of many sensors and a central computer. Radar sensors monitor the surroundings, video cameras detect traffic signals, LiDAR sensors use lasers to detect distance from the curbs or from the lane lines, ultrasonic sensors detect curbs and other vehicles, and all this information goes to a central computer within the car that controls steering, acceleration, braking, and other functions.
There are many interdisciplinary professions that work together with engineers in order to put implementation of driverless cars into cities. Many computer scientists work with city planners and traffic management to develop cars that can work in the busy cities and cause limited amounts of accidents. Engineers deal with policymakers and economists to make sure that they develop a product that will be able to not deflate the job market of transportation workers. These include public transit workers, freight deliveries, and also taxi drivers. However, the bigger question with driverless cars is when an accident does happen, who will be at fault? Will it be the pedestrian, the passenger, or the company who designed the car?
We're going to talk about the collaboration between lawyers and engineers. So first of all, insurance lawyers, we are having to determine the cause of an accident. We use software engineers and chip designers to testify in class action lawsuits on what were the decisions that were made for dealing with different accident scenarios. They will use them to assess if there were defects in the chip design, if there was a problem with the software system that made a bad decision. There will also be lawyers promoting the implementation of self-driving cars. Engineers need the lawyers to have their project adopted by a country, and the lawyers can do that by working with international laws, treaties, and federal laws. So for the taxi companies collaborating with engineers, so taxi companies such as Uber are working in partnership with car companies such as Volvo to bring self-driving cars into its network. It has invested in its advanced technologies group, home to hundreds of engineers in Pittsburgh, where it is doing much of its autonomous vehicle research.
These are the sources we used to find our information. I hope you enjoyed our presentation.